Welcome to Investigation 3.2. This should take you all the way through Investigation 3.2 so that when we do it in class, it won't be difficult at all for you to be able to do it. Our objective in this investigation is to be able to create an algorithm. An algorithm is a pattern or series of steps that allows us to multiply positive and negative numbers correctly all the time. Now, in Investigation 3.2, what we're going to do is we'll look at patterns of numbers, and then we'll be able to use those patterns as they go from large to small, and then from a small absolute value to a large absolute value, to understand how you multiply positive and negative integers. So if we look at 5 times 5 equals 25, 5 times 4 equals 20, etc., we see that every time we multiply by something one smaller, we go down by 5, which means that we can actually continue that pattern. So I bet you can guess what 5 times negative 1 is, right? If we do 5 times negative 1, we should get something that's 5 smaller. Let me put parentheses around this to distinguish it from a 5 times and then a subtraction. You're right, it would be negative 5. What if we do times negative 2, which is one smaller than that even? It should get smaller by 5. What's smaller than negative 5 by 5? Well, that would be negative 10. So 5 times negative 2 equals negative 10. Nice. So we can keep using this pattern without even really thinking about things getting smaller by 5. All we're really doing here is taking that negative sign and moving it over. So every time we have one negative sign that we're multiplying by, it goes to our answer. Let's use that to help us begin solving Investigation 3.2. We're going to do problem A first. So here I am labeling A just like you would when we do it in class. This is A1. A1 says, how, well, you can look at it in the book while we're writing. How do the products change as the numbers multiplied by 5 get smaller? Well, when we look at it, I would say that the products are changing by a factor of 5. In fact, as the numbers multiplied by 5 get smaller, each one gets smaller by 1. Each one of, maybe I should be more clear. As the numbers in this column, right here, get smaller by 1, the numbers that are the solutions get smaller by a factor of 5. These are the products. So I could say in response to our question, the products get smaller by a factor of 5. Each time the number multiplied, my hand's in the way, I'm sorry. Each time the number multiplied gets smaller by 1. Let's check that we've answered our question. Our question said, how do the products change as the numbers multiplied by 5 get smaller? We said that the products, which are these numbers right here, got smaller by a factor of 5. As the numbers multiplied by 5, here, got smaller by 1. So our answer is correct. We answered the right question. Number 2 says, predict 5 times negative 1, 5 times negative 2, and 5 times negative 3. Explain your reasoning. Now, we've actually already solved number 2. We did it together. Remember? It said to solve these 3 problems. We already did it. So I'm just going to draw a little arrow. This is 5A part 2. And here's our solutions up here. But we still haven't explained our reasoning. I would say that since, let's zoom in a little bit. Since the numbers are decreasing by 1, These are the negative numbers now. Each time, our answers, or products, should also decrease by 5 each time. Really, I'm just skip counting downwards. Decrease by 5 each time. And we're done with 5. Well, we're done with part 2. Let's check out number 3. Number 3 is asking us, write the next 4 equations in the pattern. Well, we did this, really. We did 5 times 1 is negative 5. We did 5 times 2 is negative 10. We did 5 times negative 3 is negative 15. So the answer to 3.2 part 3 is these same 3 plus our 4th equation. 5 times negative 4 equals, can you guess? Should be smaller by 5. That's right, negative 20. Let's try part B now. Part B says complete the equations below. Negative 4 times 5, negative 4 times 4, etc. This is really similar to the part up here. But we have negative numbers now. Well, we already know what negative 4 times 5 is, because we just did it. We know that 5 times negative 4 is negative 20. So I can complete the pattern for part B. B1 is negative 4 times 5 equals negative 20. Then the next one is negative 4 times 4 equals, well, this one decreased by 1, so our answer should decrease by 4. 4 times 4 is 16. This would be negative 16. Let's try it again with a 3 in the place. Decreasing by 1 again means our answer decreases by 4 again, giving us negative 12. Negative 4 times 2 equals negative, decreasing by 4 again, 8. Negative 4 times 1 equals negative 4. And negative 4 times 0 equals 0. Have we completed the equations? Let's go back and check. We have completed the equations. It only asked us to go to 0. Let's try number 2. How do the products change as the numbers multiplied by negative 4 get smaller? This is really similar to part A. I'm going to continue it on the other side because I don't have to take extra special notes. We're going to do B part 2. And the question asked us how the products changed as the numbers multiplied by negative 4 got smaller. I would say that the products decreased by a factor of 4. A factor of 4 means something that you would multiply to get them. So, oh, you know what? Since we're not multiplying, they actually got just smaller by 5. By 5. We don't have to introduce that complex vocabulary. The products decreased by 4. It just got smaller by 4. Decreased by 4. If we say by a factor of 4, that would mean we were dividing by 4. So we got to make sure we're using careful vocabulary. That was my mistake. The products decreased by 4 each time. Each time what? Each time their factors decreased by 1. So these are the factors, something that you multiply to get them. Each time their factors decreased by 1. And we're done with B2. The next problem is asking us to predict negative 4 times negative 1 and explain our answer. Well, we can do that. We did negative 4 times 0, and we got 0. So every time our numbers got smaller by 1, our products got smaller by 4. So let's continue the same logic. Negative 4 times negative 1, which is 1 smaller than 0, should be smaller by, oh no, excuse me, they're getting bigger by 4, aren't they? Because it looks like they're getting smaller, but these are negative numbers. So let's make a special note here. Negative numbers are actually increasing when they look like they are getting smaller. That's pretty crazy. So we're making a note, and I would recommend you take this note with me because it's very important. We said before that they were getting smaller each time, but really they're not, because we know that if you had a $4 loan, that's better than having an $8 loan, which is better than having a $12 loan or a $20 loan. You owe less money if you only owe $4. So really the numbers are increasing. Let's change that. The products increased by 4 each time their factors decreased by 1. So here the factors are decreasing, but the products are increasing. So if we add 4 to 0, we're adding 4 each time, we're going to get positive 4. Does it make sense in our pattern? Yes, because each time we're adding 4. Negative 20 plus 4 is negative 16, plus 4 is negative 12, plus 4 is negative 8, plus 4 is negative 4, plus 4 is 0, plus 4 is positive 4. That's very cool. So now we just have to write our answer and explain it. I'm going to put it right here. As the numbers multiplied by negative 4 get smaller, their products get bigger by 4. So negative 4 times negative 1 equals positive 4. This is very cool. This reminds us of another rule for multiplication, where if you're multiplying a negative times a negative, it turns into a positive. So this turns into a positive 4. And we can see that it fits a pattern we could predict anyway. It's getting bigger. Let's try to solve number 4 now. Write the next 4 equations in the pattern. We can do that. Let's start after negative 4 times negative 1. So if I write the next 4 equations, that would be negative 4 times negative 2 equals, well, it's got to be bigger by 4, so that would be 8. Negative 4 times negative 3 equals 12. Negative 4 times negative 4 equals, well, you know this one, 4 times 4 is 16. We have 2 negative signs, which makes a positive. And negative 4 times negative 5 is 20. Every time, they're increasing by 4, just like when we were on the other side of 0. Just like when they were negative, they're increasing by 4. And even after we get to 0, they're still increasing by 4 every time our factor decreases. Let's try part C now. Part C is asking us to find each value. What values do we have to find? Well, we're just going to quickly solve these. We have 7 times negative 8 times negative 3, and a few more. Then we can use the patterns we found in the problem and compare them to the algorithm from problem 3.1 that we used. So, I'm going to rewrite my first problem. That's 7 times negative 8 times negative 3. I'm going to put my equal sign below, and we'll just keep going. 7 times negative 8. Well, I'll do this one first because they're both multiplication, but I always do the part on the left side first. 7 times 8 is going to be equal to 49 plus 8, which is 56. There's a negative sign, so that makes it negative 56. Then I have to still multiply by negative 3, so I'll do that. Now I have to multiply 56 and 3 together. Well, I know there are 2 negative signs, so my answer is going to be a positive number, because 2 negatives multiplied together is a positive. I can do this in my head. 50 times 3 is 150. 6 times 3 is 18. So I have to add 150 plus 18, and doing that in my head is 168, which should be our answer. We are all done now. Our answer is positive 168. Let's try the next problem. This is part B. This is part A, and we have part B. Negative 12 times negative 5 times negative 4. This one's not too hard. We begin with 2 negative signs, so we know that this number is going to be positive. 12 times 5 is the same thing as 50 plus 10, which is 60. We still have to bring down this number. This is going to be equal to 60 times negative 4. We have one negative sign, so we're going to bring it down. We know our answer is going to be negative. And 60 times 4 is the same thing as 6 times 4 with a 0 on the end. So that is going to be equal to 24 with a 0, which is 240. And it's negative 240 because of this negative next to the 4. And we're all done with part B. Let's try part C now. This is 1/2 times negative 2/3 times 3. Let's try multiplying these first since they're on the left. We know that our answer is going to be negative. It'll be something negative. This is the same thing as 1 times 2 over 2 times 3. And this is 3 over 1. It's really the same thing. So that gives us negative 1 times 2 is negative 2 over 2 times 3 is 6. Then we multiply by 3 over 1. Our answer is still going to be negative because we have one negative in our problem. That's 2 times 3 over 6, which is 6 over 6, which is equal to, oh, we forgot our negative sign, which is equal to negative 1. So here, let me rewrite it just so you can see what we're doing. I multiplied across the top, so this was negative 2 times 3. That's where our negative 6 came from. And the bottom was 6 times 1. That's where our other 6 came from. So this answer is going to be negative 1. And we have one last question to solve. Let's try it. How do the patterns you found in this problem compare to the algorithm from problem 3.1? Well, in problem 3.1, we decided that if you had one negative sign, like here, your answer would be negative. And if you had 2 negative signs of numbers you were multiplying together, the answer would be positive. Did this work? I would say yes. So we can just say, as long as we remember the algorithm, that the algorithm is the same. So we can rewrite it here if we want. Negative number times a negative number is a positive number, and a negative number times a positive number in any order is still a positive number. Same algorithm. And we are done. Congratulations. You just did, with me, Investigation 3.2. Bye.